Fuel, the fastest modular execution layer, John Adler. Summary: this conversation covers multiple aspects of blockchain technology, focusing on modular execution layers, roll-ups, and the development of Fuel by John Adler's team. The speakers emphasize the advantages of modular execution layers over traditional roll-ups, such as light client support, data availability, and state growth. They discuss the drawbacks of roll-ups that prioritize call data without considering state growth, which could lead to future problems as data availability becomes cheaper. Fuel, as a modular execution layer, is designed to address these issues by offering a more balanced approach. The speakers also discuss the importance of creating modular, adaptable software that can adapt to different data and settlement layers in the blockchain ecosystem. They explore the differences between Ethereum's account-based model and the UTXO model used in Bitcoin and Cardano, as well as the benefits of using UTXOs for parallel transaction execution and improved performance. They touch on the design of the Fuel VM, a virtual machine based on Ethereum Virtual Machine, EVM, with various improvements, and how it is conducive to statelessness in the future. The conversation delves into the differences in smart contract implementations among Bitcoin, Ethereum, and Cardano, including stateless and stateful transaction models. The speakers explain how Fuel aims to combine the best aspects of the EVM and UTXO models, by allowing users to sign over actions instead of effects, leading to increased performance and flexibility. They acknowledge the trade-off of Fuel's lack of backward compatibility but argue that this is an engineering challenge that can be overcome with improved tools. The speakers discuss the advantages of modern programming languages like Rust and Sway for building reliable and efficient smart contracts, and how these languages prevent common developer mistakes that could lead to financial losses. They criticize Solidity's approach to payability and argue that wallets, not full nodes, should handle it. They also emphasize the importance of integrating safety measures and analysis within the tools themselves, rather than relying on third-party tools. The conversation highlights the Sway compiler as a premier tool for developing safe and reliable smart contracts, focusing on empowering developers rather than achieving the fastest compiler speeds. The speakers describe Sway as the safest smart contract language, due to its incorporation of learnings from previous vulnerabilities in blockchain programs and contracts. They envision Ethereum remaining a premier settlement layer for programmable digital assets, as it continues to improve its data layer capabilities through initiatives like Dankshodaying and Proto-Dankshodaying. Finally, they touch on Fuel Labs and the capture of MEV, minor extractable value, through transaction fees for block producers. In summary, this conversation offers a comprehensive overview of various aspects of blockchain technology, focusing on the development of Fuel as a modular execution layer and its potential implications for the blockchain ecosystem. The discussion emphasizes the importance of creating adaptable, secure, and efficient software solutions for the ever-evolving world of blockchain and smart contracts. Notable quotes: "State growth and state size is the ultimate bottleneck that was always the case. It's just currently obfuscated by expensive call data, and this is a transient thing. It will go back very quickly to call data is cheap and state is expensive." This quote highlights the importance of addressing state growth as a key challenge in the blockchain ecosystem. As data availability becomes cheaper, the focus will shift back to state growth as the main issue. By understanding this, developers can create solutions, such as Fuel, that are designed with the future in mind and avoid becoming obsolete in a short period of time. Modern languages are built like this: they stop you from shooting yourself in the foot, and if you try to shoot yourself in the foot, then they stop you from doing it and they give you big warnings or big errors that describe exactly what you're doing wrong. This quote emphasizes the importance of using modern programming languages that inherently prevent developers from making common mistakes. These languages have built-in features that enforce safety and provide clear warnings or errors when something is done incorrectly. By using such languages, the possibility of creating vulnerable or inefficient smart contracts is significantly reduced, ultimately leading to a more secure and reliable blockchain ecosystem. Content type: podcast interview. Content publisher: Blockworks. Publish date: January 2023.